Hello again. We're going to be working problem number 2 found in lesson 3-4. This is found on page 166 of your textbook. But before we do, I want you to look up here at the perpendicular transversal theorem. And I just want to read this to you because that's what this problem is actually going to deal with. It says, in a plane, if a line is perpendicular to one of two parallel lines, then it's also perpendicular to the other. So what they're talking about here is if this line right here is perpendicular to line L, but L is parallel to line M, then if it's perpendicular to L, it's also going to be perpendicular to M. That's what this rule is saying. Okay, now let's use this in a proof over here. Let me pull this problem up a little bit. We're proving that in a plane, first of all, you're given that C is perpendicular to B, okay, which is this right here, and that B is perpendicular to D, which is this right here, and that D is, this line right here, is perpendicular to A, which is right there. Okay. What we're trying to prove is that C is perpendicular, line C is also going to be perpendicular to A. If it were to extend out here, would it be perpendicular? And here's the proof. This is not a formal proof or a two-column proof. This is just what we'll call a paragraph proof, where you're just kind of explaining yourself in sentence form. Lines C and D are both perpendicular to line B. So what it's saying, both of these are perpendicular to line B. Okay? Because two lines perpendicular to the same line are parallel, then it is given that D is perpendicular to A. That was the last one that was given to us. Therefore, C must be perpendicular to A, because a line that is perpendicular to one of two parallel lines is also perpendicular to the other. So what we're saying is, since that line is perpendicular to both of those are perpendicular to B, then that means that these lines are parallel. And so if this one's perpendicular to A, then C is going to be perpendicular to A as well. Okay, that's the thinking. That's what they're trying to explain and all that. Now, in the got it section here, it says in problem 2, could you conclude that A is parallel to B? And the answer is yes, because again, if B is perpendicular to D, and it is right here, and A is perpendicular to D, if that line is perpendicular to both of these lines, again, according to that, if one line is perpendicular to two lines, then these two lines must be parallel to each other, which concludes or helps me conclude that A must be parallel to B. Because if D is parallel to B, perpendicular to B, but D is also perpendicular to A, then A and B must be parallel to each other for that to be true. Okay? And that's just, again, trying to get you to think of the rules that are given within this short section. Best of luck.